We are ancient and living. We are India. Let's dive into the stories of last 5,000 years that shaped us. Imagine looking up at the night sky over 1,500 years ago, with no telescopes, no satellites, just the brilliance of the stars and the mysteries they held. Now, picture a young scholar, deep in thought, using only his mind and ancient tools to unravel the secrets of the universe. This was Aryabhata, an extraordinary figure whose revolutionary ideas would not only change the course of Indian science but resonate across the world for centuries. How did he calculate pi with such precision? And what led him to challenge beliefs by explaining eclipses with logic and mathematics? Let's step into the world of Aryabhata, the trailblazer who dared to think differently. Born in 476 CE, Aryabhata was raised during a time of rich intellectual and cultural growth in ancient India. Although the exact location of his birth remains debated, many scholars believe he hailed from the region of Kusumapura, modern-day Patna, where learning and scholarly pursuits thrived. From a young age, Aryabhata was captivated by the mysteries of mathematics and the movement of celestial bodies. He would later become the head of an esteemed educational institute, possibly Nalanda, where he authored his magnum opus, the Aryabhatiya. This groundbreaking text would set a new standard for astronomical and mathematical thought and solidify Aryabhata's place as one of history's greatest minds. Aryabhata's journey into advanced mathematics stemmed from a deep-seated curiosity about the natural world and its inherent patterns. Living in an era where astronomy and timekeeping were essential for agriculture, festivals, and navigation, Aryabhata realized that more precise calculations were needed. This pursuit led him to refine the value of pi. While earlier mathematicians had used rough approximations, Aryabhata employed rigorous geometric methods, observing circular arcs and their relationships to diameters. His groundbreaking calculation of 3.1416 not only improved the precision of mathematical models, but also influenced future geometric studies and engineering. Similarly, the need to better understand celestial movements inspired Aryabhata to develop trigonometric concepts. Observing the moon's phases, the sun's path, and the positions of stars, he understood that existing arithmetic could not explain these phenomena effectively. He introduced the sine function, which he called jya, to facilitate the measurement of angles and distances in the sky. By creating detailed sine tables, Aryabhata provided tools that allowed for more precise predictions of planetary movements, making trigonometry an indispensable part of both astronomy and mathematics. While his mathematical contributions were profound, Aryabhata's astronomical insights were equally revolutionary. In a bold departure from prevailing beliefs in 499 CE, he proposed that the Earth rotates on its axis, explaining the apparent movement of the stars. Aryabhata also provided a scientific explanation for solar and lunar eclipses, attributing them to the Earth's and Moon's shadows. A view far ahead of his time, he meticulously calculated the orbits of planets, setting a precedent for future astronomers. Aryabhata even measured the sidereal year at 365.25858 days, a calculation remarkably close to modern measurements. In the year 499 CE, Aryabhata at just 23 years old, composed one of the most influential works in the history of mathematics and astronomy, Aryabhatiya. This concise yet profound text was a comprehensive guide that showcased Aryabhata's revolutionary insights into mathematical calculations, astronomical observations, and timekeeping. Written in verse form, Aryabhatiya was composed in Sanskrit, making it both a scholarly masterpiece and a work of poetic elegance. Its content was so ahead of its time that it would require future scholars to write detailed commentaries to unlock its full meaning. Aryabhatiya is structured into 4 key sections: Gitikapada focusing on time, Ganitapada on mathematics, Kaalakriya on calendric calculations, and Golapada on spherical astronomy. Its concise, formulaic style required detailed interpretations from later scholars like Bhaskara first, who helped decode Aryabhata's profound ideas. Aryabhata's work didn't remain confined to India. Translations of Aryabhatiya reached the Middle East, influencing scholars like Al-Khwarizmi, whose work laid the groundwork for algebra. Through these exchanges, Aryabhata's ideas found their way into Europe, contributing to the intellectual revival that fueled the Renaissance. Today, Aryabhata's contributions echo through history, inspiring generations of scholars and mathematicians. As he once said, "As the earth revolves around the sun, so do ideas and knowledge span across ages." Aryabhata's work continues to remind us of humanity's relentless pursuit of knowledge. His legacy lives on, illuminating our understanding of both the cosmos and the mathematical principles that govern it. Thanks for watching, and do join us for more such videos on ancient India.